Hey, what's up everyone? This is me Arnab welcoming you to the 7th episode of Learn Angular. In case you have arrived here for the first time, in this series we are learning the basics of Angular framework while building an e-commerce project. In the previous session, we have completed the payment gateway integration. So today I have planned to introduce you all with Angular library. And in the next couple of episodes, I'll dedicate for Angular monorepo concept and progressive web applications respectively. Alright, so what is an Angular library? On a very high level, it is a collection of pre-compiled routes which include services, components, directives, etc. basically shared across different Angular projects for reusability. Unlike an Angular application, library cannot run on its own until it is integrated with an application. So these libraries can be used locally in your workspace, or you can publish them as npm packages to share with other projects which are not present in your local system. For example, our project has add to cart functionality, which is built using multiple component services, etc. Now, if we want to implement something similar in another project, we can pack these components to a add to cart library and use it in other Angular projects. This is the most generic use of Angular library, but today we'll do something else. But before getting to all this, I have a problem for all of you. So suppose you have an e-commerce product, okay? You own an e-commerce product and you got a customer for this product as well. Imagine it is XYZ company. Now they have one condition, that is the customization on top of the product will be done by their developer and not yours. What that effectively means is you need to hand over your product source code to the client's team, okay, for them to continue the development in their local PC. Now, if we do so, obviously therein lies a thread of code theft, right? So we need to find a way to expose the product to the customer team so that they can use the product but cannot clone it or see the source code basically. If you know the solution, please comment down below. So today we'll convert an existing Angular 10 application into a Angular library which can be reused in other projects without exposing the original source code. First of all, this is what we have developed till now. Let me log into the application. Great. Now I want to add a couple of pudding and one chocolate ice cream maybe. Fine. So this is how the card screen looks after that. Now, step 1 is to navigate to app folder. Here, IDM and product folders mainly contains our project feature. So, we'll convert these two modules into a shop library. The core mainly contains generic project configuration and we should leave it to the application side. Now, we need another workspace to which we'll create our shop library. I don't want to create a default application right now, therefore create application flag is false here. With the help of Angular CLI utility command, we will have a workspace inside which we can create our application and library. Now the next thing is to generate a shop library called Shoplib. So as I mentioned, after the library is generated, we need to create an application and we'll copy this core folder inside that application. But before doing so, we'll copy this two folder into shop library. All right. Then the next step is to copy the core folder contents into an application which we are about to create now. scss for styling we need. Done. Before moving the core folder, here let us remove the existing app components and modules from here first. These are default files which we'll modify according to our need. Now we need to do a bunch of stuff. First, let's open the code base in VS Code editor. Since the app module is inside core folder, we need to fix this path in main TS first. Okay, so that was easy. Now, before going ahead, we'll copy the app config service and pipes folder from this core folder into Shoplib. As they are very much specific to the library, hence we can't expose it, right? Basically, we need to take out everything from the application which impacts the library. Next, just copy the assets and environment folder into the newly created shop app. Only because we are trying to make a clone of our existing application, so everything should remain same, but it is up to the customer team to customize this. Replace everything. Now we have the same environment properties here as well. Since we don't have a core folder inside our library, I'm checking now if there is any import path which still refers to the files in core folder. Well, here we can see a couple of red lines, but these are different issues. I'll get back to them later in some time only. So inside dashboard we need to change this app config path. Great, it is resolved now. So same goes for filter pipe as well. Since their location is modified now. Now heading towards the shop app. For now, I'm commenting these lazy loaded routes. Soon we'll replace them with the newly created micro frontend. Just wait and see. Now, as I was saying, coming to the Stripejs thing, let's quickly add this dependency in our workspace. Simplest way for that is to use npm add. So this command will add Stripejs as a dependency into our project. Once that is done, we will learn how to access environment variable from a library. Since you all know, library is a completely standalone bunch of code, and we can't directly import any specific environment here. Instead, library, or I should say environment, should be provided by app module itself. So if any other application uses the same library, it is the responsibility of the application to provide the environment. Here, by adding this @inject stripe key dependency, we are expecting that its parent module will provide them an injection token with the same name, that is stripe key. Just moving the load stripe call statement inside constructor now. Okay, now the second part. Here I came to the app module to provide the stripe key value. Like we did for base URL. Great. Now if everything works fine, we'll receive the value of stripe key here inside cart wrapper component. Awesome. So the last step before we can test our application is to add the scripts and scss entry inside AngularJSON. Here we just need to modify the path as per our application location. Since we are inside shop app configuration, it is safe to add the hard-coded values here. Now let's quickly build the library code. Great. So the library is built successfully, but we haven't exposed any of our code from the library. Therefore, effectively it is still the same generic library, boilerplate, which CLI provided us. Let's add these two modules one by one here in public API file. Unless we add our files here, it won't be accessible from the application side. The last import is for product component, which we are explicitly importing in our app routing module file. So this is where all these items will be used. But before that, let's rebuild the application library first. You should explicitly provide the external module identifier by using this UMD module IDS. This goes into the libraries package file section. Now that warning will be gone. This is the dist content which we have got after successfully building the shop library. Under lib folder, you will find all these files with .d.ts extension. They basically hold the type information of these files. The TS files are now converted into their JavaScript equivalent after uglification and minification process. So this is how the login component looks after build. Similarly, this is how the IDM routing file looks. Finally, as our library is up and running, it is time to uncomment these routes. Okay, I think this import is unused here. Let's remove it. Now we can get products component from our newly built library only. For this only, I have exposed this from the public API file. If we open ts config base.ts, ts config base.ts, under paths key, we can find this shoplib key, which refers to the dist content of it. So this is done by CLI, which generates these codes while generating the library itself. We will use this key to refer our library from the application side. Same way as we have IDM module exposed from the library side, we can alter this import path with simply shoplib. Same goes for product module as well. So ideally, this should be enough to test the library code. Oh, I forgot to include FontAwesome CDN path inside the index file. So FontAwesome we are using for all the icons, delete icon, plus icon, all the icons. MongoDaemon is also up now. As expected, we have made a replica of our existing Angular application here, but this time we are using a library. Testing the payment part now. And it's a success. Now, if we open the Stripe payment page for a final confirmation, what do we see here? Let's check. Right now it's 9:37, 20th Jan. Yeah, so this is the payment I just now made of 870 rupees. As everything seems in place, it is time to delete this entire shoplib folder, as the build version is functioning great from the dist folder. Now we arrived at the last stage of this session. Here we'll pack this library and install it from a different workspace. I think that's what I committed initially. So this command will create a tarball version of the shoplib, our library basically. So here it goes. These are the resultant tarball details. This is the file which holds the entire library content, and it can be installed from any other workspace. To test this, let's come out of this current workspace and create another new workspace. Now change the directory to this new workspace. Here we want to use the IDM module for Shoplib. To achieve that, we need to install our locally created shop library from the previous workspace. The command remains same, the way we install any npm package. Only difference here is we need to supply the tar file location path here along with this. This is the file location. Basically, this step will copy the library into the node modules folder of our current workspace. Alright, now that we have successfully installed the local library, we can alter this path with Shoplib like we did before. So this is just to confirm that we have added Shoplib as a dependency to our project. This is how it appears in package.json. As you can see, it accepts our library without showing any error. And with this final step, it is time for me to wind up today's session of Learn Angular. Using npm publish command, now this library can be shared globally as well. So, if you find my content helpful, please hit the like button and subscribe to my channel. Thank you for watching.